Phew, I finished all my stats. Damn it, I am playing Elite today. Oh well, I guess I can't play Elite today. Albert, what are you doing?
Oh, I'm studying for stats, Dad.
No, what were you actually doing?
I was writing my book analysis.
Open that thing back up.
What? I was studying for stats. No! Dad, no!
What is this?
This is stats, Dad.
A game?
No, it's not a game. No!
This computer's
no!
mine. Hey, Albert.
Screw you! Shut up!
Oh, why are you so mad?
My dad confiscated my computer
Why?
because I was playing League at 3:30 a.m.
Really?
Dude, I can 1v1 you anytime. Shut up, you bronze 5 noob. Why are you so mad? I'll 1v1 you. Dude, I can Shrek you, man. Okay?
No, I'm gonna beat you.
Dude, I don't even have my laptop. I can Shrek you without my laptop, okay?
We can use school computer.
Okay, let's go. Albert, okay.
I kill you. I kill you. Oh no 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 no. Aww. That was unfair.
Holy shit, this champion's broken.
Oh my god, that was actually a one shot. What the hell? No! Oh no! What? Oh my. No! Oh my god! Whoa!
This is so stupid.
Oh my god, you're so low! How did you survive?
Zero's broken. So stupid.
Oh wait, oh shoot. Whoa! WQQ. Oh no! I'm just spamming keys now.
Oh my god, this is so stupid.
Oh no! Okay, good game, whatever. I get this game.
Oh, stupid.
Wow, this defeat screen looks so beautiful.
Dude, look how many hours you have. 16,660 hours? Are you crazy? How do you expect me to 1v1 you?
Are you just being salty right now because
I'm
I
not-
beat you?
No, I'm not being salty. I'm stating the fact. I'll conduct a statistical experiment to prove you wrong.
Okay, let's bet on it.
Let's
then.
bet.
Such a stupid bet.
For this statistics project, in order to conduct a linear regression, we need a random sample of summoner IDs, or players. In order to get this random sample of players, I turned to a Python program, which I programmed in order to pull data from the game servers. I'll briefly go over the program before talking about the left side in a second. First of all, this part of the program basically pulls the data from the servers and returns a JSON file, which is similar to a very complicated dictionary. Second of all, because tier is actually a categorical variable, such as silver, gold, platinum, or diamond, we need to actually convert that to a quantitative variable to do a linear regression, which we do in this step here. Later on, in the main method, we actually calculate the number of games played that a particular player has, and that we can compare it to the number to his rank point or the quantitative variable that we just converted, and we plot those into an Excel file, which we later do a regression on. Now on the left side, the reason why you see so many 404 errors is simply because a lot of players have yet to play a ranked game, and this API is only able to retrieve ranked games, and so if a player hasn't played any of those, we can't find the player, and hence the 404 error. Now when you actually see a player information bubble pop up, that's when a player has played ranked matches and we can actually see their number of games played. For this statistics project, we're doing a linear regression. So for a linear regression, we use a 4-step process. We're starting first with the state part. First of all, we're testing two hypotheses. First of all is the null hypothesis, or H naught, which we have as beta equals to 0. Second, we have HA, which is the alternative hypothesis as beta greater than 0, where beta in this instance is the true slope of the regression line relating the number of games played versus league points, which is an indicator of how good a player is at this game. Now moving on to why we set the alternative hypothesis as beta greater than 0. We believe, and it is reasonable to assume, that a player would get better as he plays more and more games. For a linear regression, let's first check if we need to transform the data, because if any transformed data produces a regression line with a greater R value than the original data, it is better to use that transformed data instead. So let's look at the R values of these graphs that I made. So first of all, we have the standard graph with rank points being compared to games played. Then we have the graph with rank points being compared to natural log of games played. And we have natural log of rank points being compared to games played, and the natural log of rank points being compared to natural log of games played. Onto the R values. So for the first graph of games versus points, R value was 0.42491. Graph in which natural log of games and plotted it against points, the R value was 0.34459. For the data in which we took the games versus the natural log of points, R value was 0.2391913. For the last graph where we took the natural log of both games and points, the R value was 0.27028. So we can clearly see that the first graph, or our original data, had the highest R value of 0.42491. Therefore, we are going to use that for the linear regression. The first condition that must be met is linearity, which is that the graph of the scatterplot must appear roughly linear. Now, this condition appears to not be met because of the curve pattern that appears to be in the scatterplot, almost like a log function, but we will proceed as if this condition were met. Before we check the conditions for a linear regression, let's first check if we need to transform the data, because if any transformed data produces a regression line with a greater R value than the original data, it is better to use that transformed data instead. So let's look at the R values of these graphs that I made. So first of all, we have the standard graph with rank points being compared to games played. Then we have the graph with rank points being compared to natural log of games played. And we have natural log of rank points being compared to games played, and the natural log of rank points being compared to natural log of games played. Onto the R values. So for the first graph of games versus points, R value was 0.42491. Graph in which natural log of games and plotted it against points, the R value was 0.34459. For the data in which we took the games versus the natural log of points, R value was 0.2391913. For the last graph where we took the natural log of both games and points, the R value was 0.27028. So we can clearly see that the first graph, or our original data, had the highest R value of 0.42491. Therefore, we are going to use that for the linear regression. The third condition that needs to be satisfied in order to do a linear regression is the normality condition. By producing a dot plot or a histogram of the residuals, we're able to tell if there are any clear outliers or a skew in that residual plot. There appear to be a couple outliers, however, but we will proceed as if this condition were satisfied. The fourth condition is the equal standard deviation condition, which says that standard deviation must be approximately equal at all x values. Now, this appears to also be roughly true according to the residual plot. The last condition that needs to be satisfied is the random condition. Because our program randomly selected numbers from 1 to 50 million as players, this condition is satisfied. Now that the conditions are satisfied, we can do our significance test. We use the formula b minus beta naught divided by the standard error of b equals t, where b is the slope of the sample regression line in our data, and beta naught is the slope indicated by the null hypothesis, which is usually 0, which is 0 in this case. And the standard error of b is the standard error of the slope of our sample regression line. Plugging in the numbers for b and beta naught and SE of b, we get a t-value of 7.392. Using df equal 250 minus 2 equal 248 because this is a linear regression, and using tcdf, we obtain a p-value so small that the calculator says it's 0. Because p equal to 0 or less than 10 to the negative 99, because that's the minimal value that the calculator can display, we reject HO. We have convincing evidence that there is a positive linear relationship between games played and rank points in League of Legends players.
You'll never find it here. Aha.